Okay, we're still in section 6.3. I was going to finish that up now. I was going to talk about basic trig identities next. Now, when it comes to identities, we're going to be doing lots of things with identities in the next chapter. And quite honestly, most of the identities that you'd ever work with in trig are not ones that you need to have memorized or anything. They're really just kind of, computational exercises. But there are some identities that you should be memorizing, okay? Just because they come up a lot and they're just worth knowing. The reciprocal identities, we've already been using those. So that would be, actually by definition, how we define cosecant theta is it's the reciprocal of sine theta. By definition, how we define secant theta is that it's the reciprocal of cosine theta. By definition, how we define cotangent theta is the reciprocal of tangent theta. Okay, so these are not new identities, like we've already been using those just because of how they were defined. The quotient identities would be new here. So tan theta is y over x. Okay, y over r divided by x over r. If you flip the denominator, the r's would cancel there. Now, why I have it written like this is because sine theta is y over r and cosine theta is x over r. So tan theta is the same as sine theta over cosine theta. Cotangent theta is the reciprocal of tan theta, and so in terms of sines and cosines, it would be cosine theta over sine theta. Okay, those are identities that you'd want to know. And then there's Pythagorean identities. These are ones that you would want to have memorized also. So I'm going to talk about that now. Suppose that we have a circle of radius r centered at the origin. Okay, so h and k are both 0. And in this equation, let me divide both sides by r squared. So x over r, well, that's how we define cosine theta, right? Adjacent over hypotenuse. Y over r, that's how we define sine theta, opposite over hypotenuse. And so cosine theta, the quantity squared, plus sine theta, the quantity squared, equal 1. Now cosine theta, the quantity squared, that's the same as cosine squared theta. Sine theta, the quantity squared, that's the same as sine squared theta. Sine squared theta plus cosine squared theta equals 1. That is one of our Pythagorean identities. There are 3 Pythagorean identities, and it's customary to write sine squared theta instead of sine theta, the quantity squared, although they both mean the same thing. Now, in this identity, sine squared theta plus cosine squared theta equal 1, if you divide both sides by cosine squared theta, then cosine squared theta over cosine squared theta is 1. 1 over cosine theta is secant theta, so 1 over cosine squared theta would be secant squared theta. Sine theta over cosine theta is tan theta, and now you're squaring that, so you'll have tangent squared theta plus 1 equals secant squared theta, or if you subtract tangent squared theta from both sides, secant squared theta minus tangent squared theta equals 1. That is another Pythagorean identity. The third Pythagorean identity would be if you start with the sine squared theta plus cosine squared theta equal 1, and then divide both sides by sine squared theta. Okay, if you do that and simplify, you'll have 1 plus, okay, it's going to be cotangent squared theta equals cosecant squared theta. If you subtract cotangent squared theta from both sides, then cosecant squared theta minus cotangent squared theta equals 1. Now, all 3 of these are worth memorizing. They will all 3 come up a lot in calculus, and also for some things that that we're doing here, obviously in pre-calculus. Now, there are lots of identities, okay, but really just the ones that I've mentioned so far are the only ones that you need to have memorized, okay? There will be some other ones later down the road that you would want to have memorized when you get into calculus. I will indicate those later on once we do some more things with identities in chapter 7, okay? But for now, these would be the only ones, if in class, I'd be telling you these would be the only ones that I'd want you to have memorized. So let's take a look at some examples. We're going to find some values here. Okay, and of course we mean exact values. We're not going to go to the calculator. We don't need a calculator for any of this stuff. Tangent of an angle is the same as sine of an angle over cosine of an angle, right? And so sine of 23 degrees over cosine of 23 degrees, that'd be the same as tangent of 23 degrees. And tangent of 23 degrees minus tangent of 23 degrees, that'd be 0. Okay. In this problem, 1 over secant squared of pi over 8, that would be the same as cosine squared of pi over 8 using the reciprocal identity. And sine squared of an angle plus cosine squared of an angle is always 1. It does not matter what that angle is. Okay, pi over 8 is not one of my common angles. That's okay. Sine squared of the angle plus cosine squared of the angle is 1, so I can go right to the answer, and I know the answer is 1. Here's another one. Tangent of 200 degrees times cotangent of 20 degrees. Well, the tangent function is periodic. All 6 trig functions are periodic, but the tangent function is periodic where the periodic factor is pi radians, or 180 degrees. So tangent of 200 degrees, that'd be the same as tangent of 20 degrees, right? In terms of sines and cosines, you have sine of 20 degrees over cosine of 20 degrees times cotangent of 20 degrees. That's the same as cosine of 20 degrees over sine of 20 degrees. These all cancel. Going to leave you with 1 as the answer then. Part D. Okay, here's one of my Pythagorean identities here. Now, secant squared of theta minus tangent squared theta is 1. If I multiply both sides of this equation by -1, then tangent squared of an angle minus secant squared of that angle is -1. So this would be, just to go right to the answer using this identity, the answer is -1. All right, the last thing I want to talk about in this section is even and odd properties. We looked at even and odd functions when we did the algebra part of the class. A function is even if f of negative theta, in this case, is the same as f of theta for all theta. A function f is odd if f of negative theta is the same as negative f of theta for all theta. Okay. Same as what we had talked about in algebra. Okay, let point P, which has coordinates x, y, be a point on the unit circle that corresponds to an angle theta. Then negative theta will have coordinates x, negative y. Why would that be? Well, if the angle happened to be like a 45-degree angle, you're in quadrant 1, negative 45 degrees would put you in quadrant 4, right? And therefore, y would be a negative since you're below the horizontal axis there. Okay, sine of theta is defined to be y over r, right? Sine of negative theta would be negative y over r, and I've got a negative then in front of y over r, so I'd have a negative in front of sine theta. Sine of negative theta equals negative sine theta. That would mean that the sine function would be an odd function. Okay, cosine of theta is defined to be x over r. So if I were to calculate cosine of negative theta, well, negative theta only affects the y-coordinate, right? So I'm going to be at the point x negative y, and that doesn't change anything here. I'm still looking at x over r, which is how we define cosine theta. So cosine of negative theta, same as cosine of theta, which means that the cosine function would be an even function. And by the way, remember that the only reason why we care about even and odd functions is because an even function is symmetric to the y-axis, and an odd function is symmetric to the origin. We'll be using that information later on in the next section, okay? But it's because of that connection with symmetry is the only reason why we care about even and odd functions. Go to the next one here. Tangent of negative theta. Well, tangent of an angle is the same as sine of the angle divided by cosine of the angle, right? Sine of negative theta, we've already said, is negative sine theta. cosine of negative theta is the same as cosine theta, since the cosine function is even and the sine function is odd. But sine theta over cosine theta is one way to define tan theta. You got a negative in front of that. So tangent of negative theta is the same as negative tan theta, which means that the tangent function is odd. Okay. The cosecant function is going to be odd because the sine function is odd, right? And you're also using a reciprocal identity there. The secant function is going to be even since the cosine function is even, right? And you're using a reciprocal identity there. The cotangent function is going to be odd since the tangent function is odd. And again, I'm using sines and cosines, but I'm also using the reciprocal identity there. Okay, so all 6 trig functions are either even or odd, right? The cosine function and the secant function are even. The others are odd. And all right, so let's take a look at, here's my last example. Find each value. Again, we're not using a calculator. Sine of negative 135 degrees. Okay, well, the sine function is odd, so sine of negative theta, that's the same as negative sine of theta. Sine of 135 degree, well, an angle that would be 135 degrees would be in quadrant 2, and you'd be creating a 45, 45, 90 right triangle, although it would be in quadrant 2. The opposite side would be 1. The hypotenuse would be root 2. Now there's a negative in front of that, so negative 1 over root 2 would be my answer. By the way, of course, I didn't need to use the fact that the sine function was odd. Like, I could have drawn an angle in quadrant 3, you know, just setting up a 45, 45, 90 right triangle in quadrant 3. And that angle, of course, would be negative 135 degrees. I'd still get the same answer, right? Because the opposite side would be a negative 1 in that case, since you're below the x-axis there. Here's part B. Secant of negative pi over 6. Well, the secant function is even, so that'd be the same calculation that, or the same result that you'd get if you were to compute secant of pi over 6. Pi over 6 is same as 30 degrees, right? So I'd build my 30, 60, 90 right triangle. Now, cosine of 30 degrees, cosine of an angle is adjacent over a hypotenuse. And in the case of a 30-degree angle, the adjacent side would be root 3. The hypotenuse would be 2. So cosine of pi over 6 would be root 3 over 2, but we'd want the reciprocal of that, right? 2 over root 3 would be the value that you'd get there for secant of pi over 6, which would also be the same as secant of negative pi over 6. Here's part C. Sine of 70 degrees divided by, okay, so cosine of negative 430 degrees, that'd be the same as cosine of 430 degrees, right? The cosine function is even. The tangent function is odd, so tangent of negative 70 degrees, that'd be the same as negative tangent of 70 degrees. And that's how I'd want to think of that, because then I don't have any of these negative angles in the calculation anymore. That's good. I also want to use the periodic factor, right? So 430 degrees would be the same as 70 degrees plus 360 degrees. The cosine function is a periodic function of periodic factor 2 pi radians, or 360 degrees. So cosine of 430 degrees, that would be the same thing, that same number that you would get for cosine of 70 degrees. Sine of 70 degrees over cosine of 70 degrees is tangent of 70 degrees. You're subtracting tangent of 70 degrees, so the answer there would be 0. Okay. So that's all I had in this section. We're now done with section 6.3. The homework is on page 405, and you can begin looking at those problems for me.